Well, hello and welcome back to math class. Hopefully you guys all enjoyed your day off yesterday. Today we are going to be writing equations in two variables. So if you could write this down in your notes for me, please. Now remember, if you need to pause the video so that you can get this written down, please do that. All right, well, the first thing we're going to do is we are going to have an equation, and the equation is going to say y equals 2 times x. And so if you could write that equation down for me. Now I'm going to give you a solution, and the solution I'm going to give you this time is going to say 3 and 6. Now if you remember with ordered pairs, the first ordered pair is always my x, and the second ordered pair is always my y. So we're going to substitute 3 and 6 in over here for my equation. So obviously for y, we're going to substitute 6. And then for x, we're going to put in 3. All right, well, let's see. 6 equals 2 times 3 is 6. So we would say, yes, the solution is correct. 6 equals 6. All right, let's try another equation. Let's write down this equation. Y equals 4 times x minus 3. Now the solution I'm going to give you this time is going to be 4 and 12. That's my ordered pair. Now remember, with an ordered pair, the first number listed is x, and the second number is y. We're going to substitute these in over here. So for y, we're going to put a 12. Copy everything down. For x, we're going to put 4. So now we're going to simplify this equation. Over here we still have 12 equals 4 times 4, that's 16. 16 minus 3 happens to be 13. 12 equals 13. That is not correct, so we put does not equal. So this would not be a solution. So we could just kind of write here, not a solution. That ordered pair is not a solution. All right. So I'm going to give one to you that I'd like for you to try. It's y equals 7 times x, and the solution that I'm going to give to you is 2 and 21. So if you would substitute those in over here for me and let me know if 2 and 21 are a solution. All right, well, let's see what you did. All right, this is x, this is y. What goes in for y? 21. We copy the equation. Instead of putting in x, we're going to substitute in the 2. Well, doesn't look good, does it? So now we have 21 equals 7 times 2 is 14. I would say that that is not correct. So 2 and 21 is not a solution. Okay. Last one, let's try this one. The equation is y equals 5 times x plus 1. Would you see if 316 is a solution? Okay, so let's see. The first one is an x, the second one is my y, so 16 is going to go for my y. 16 equals 5 and 7x, we're going to say times 3, plus 1, copy everything down. This still says 16. 5 times 3, that's 15, plus 1, is 16. So this one worked. 316 is a solution. All right, so the equations that we've been looking at have two variables. They have a y and an x, two variables. Well, one of those variables is called an independent variable. So if you would write that word down here, independent variable. An independent variable, we'll put a little slash right here, is the quantity that can change freely. So for example, I could pick any number I wanted here to put in for x. 1, 2, 3, 4, 5, 6. Whatever I put in here, it can change to whatever I want it to. But whatever I make this variable is going to change what y is. And so our other variable is called a dependent variable. And so we're going to need both of these terms in our notes. So we have the independent variable. It can change freely. And then we have a dependent variable. And the dependent variable does exactly what the definition says. It depends on the independent variable. So for example, when we had this equation here, y equals 7 times x. I can put any number I want in for x. It's independent. I can put a 7 or a 3 or a 9 or a 10, whatever I want to. And because I can put any number in here, this is called my independent variable. The problem is whatever I put in here is going to determine what y is going to equal. And so y, I can't make it anything I want. Y has to be dependent on whatever I put here for my x. And so most of the time our y right here is going to be considered my dependent. It depends upon what I put in for my x. All right, so hopefully you have this all written down. All right, so let me give you an example of an equation here. Let's see if we get the light better on our screen. All right, so I'm going to give you an equation, and the equation is going to go with a story. My equation is this. Y equals 10 times x plus 25. This equation is going to represent the amount of dollars in your savings account after X weeks. So I already have $25 in my savings account. Every week I get an extra $10. And so 1 week, $10, 2 weeks, $20, and so forth. Whatever my week is going to determine how much money I have in my bank account. So if I would say, which one of these is my dependent and independent variable? We would say that X in my story is my independent, and y is my dependent. Why? Because my x variable is going to change. I'm going to have 1 week, I'm going to have 2 weeks, I'm going to have 3 weeks. This is always going to change freely. Whatever this number is going to determine what y is. And so y is dependent on whatever x is. Let's say that I tell you I would like for you to solve this if I told you that x is going to equal 8 weeks. How much money would I have in my account in 8 weeks? So we would take this equation. We would take the x out, substitute in 8. 10 times 8 is 80 plus 25. We would say that my final answer would be I would have $105 in my bank account. All right, so I'm going to show you one more thing that I'd like for you to put in your notes, and it's very similar to what we've been doing in our Math 5 a Day. So for example, my equation is going to be y equals x plus 2. So I'd like for you to write that equation down. We're going to make a chart. We're going to have here our independent variable, and we're just going to put it like this. Our independent variable is x. I'm going to make a column. We're going to put here our dependent variable, and that's going to be y. And we're going to make a chart. And then over here, we're going to list our ordered pair. And that would be considered my x and my y. So for example, if I gave you the numbers for your independent as 1, 2, and 3, we would need to solve for y. So for example, I would take this 1 and I put it up here in this equation for x. So this would be 1 plus 2. What does that equal? That equals 3. So my ordered pair over here would be 1 and 3. If I would take a 2 and I'd stick a 2 up here, what's 2 plus 2? Makes 4. So my ordered pair is 2 and 4. 3. All right, let's put a 3 up here. 3 plus 2 is 5. So my ordered pair is 3, 5. Now, after using this equation right here, making a chart, I could actually plot points and graph this. So in our notes, what we're going to do is we're going to make, see if I can move my camera here a little bit. All right, there we go. We're actually going to make an x and y axis. So we're going to go something like this to just kind of have some notes. This, of course, is my origin. It's going to be 0. This is my x-axis. This is my y. If I kind of put some tally marks here, for example, 1, 2, 3, 4, and 5. And then we'll do the same thing here. 1, 2, 3, 4, and 5. If I wanted to plot my first point right here, it's going to be over 1 up 3. So I would go down here on my x-axis, go over to the 1. And then I would go up 3, and I'd plot a point. If I wanted to do 2, 4, I'd go over here to the 2. And then I'm going to go up here to the 4 and plot a point. And then finally, over 3 up 5. Here's my 3. Over here, oh, 5, and plot a point. This is very similar to what we've done in our Math 5 a Day. So hopefully you can understand how to do this. We're going to actually do a little bit more tomorrow on this. All right, you can go ahead and stop your video.